The purpose of this segment is to reinforce what you may have already read about scatterplots, but also present you with a little bit of communication, video, audio communication about scatterplots themselves. First of all, scatterplots are a bivariate display of data. In other words, when we look at a scatterplot, we're seeing information. We're seeing two pieces of information for each member of our sample. Two pieces of information for each member of our sample. So each case in our data set, regardless of what we're analyzing, whether it's people or cars or neighborhoods or cities or countries or tires or whatever the case may be, each case in our sample is providing two pieces of information. Now, if you haven't yet downloaded and printed, or at least have on your screen, two handouts from the folder for this week. One handout in the folder is called Scatterplot Intro, and the next item is right below it, and it is called Scatterplot Smoking X Colds. Now, what that X means in that context is simply by, like we're running something by another or crossing one variable with another variable. But let's rewind a little bit. I'm going to refer to the handout called Scatterplot Intro. So if you don't have it yet, go ahead and pause this video and go download that and display it on your screen, or print it and so you have it in your hand or have it in front of you as I'm talking about it. The handout I'm referring to looks like this. This is just a generic example of a scatter plot, and I want to point a couple of things out about it. Okay? First of all, we have two axes, an x-axis and a y-axis. The x-axis is the horizontal axis, it goes side to side, and the y-axis is the vertical axis, it goes up and down. So two axes, and they are referred to as the x-axis and the y-axis. In addition, sometimes it will be necessary to specify one of the two variables in your analysis as an independent variable. That's in part why we did some of the work some time ago about independent versus dependent variables. And the independent variable, the variable that we anticipate will have some sort of an effect, is typically plotted along the x-axis, and that's why I've written here independent variable. Through the process of elimination, you probably can figure out that the y-axis is where or how we plot the dependent variable. In addition, sometimes it's necessary to know the coordinates of specific data points or cases in our scatter plot. And as you can see from this example, I have placed onto this generic example 5 cases or 5 data points, and I have also indicated their coordinates, their XY coordinates below each dot, each data point. So each dot in this scatter plot represents a case or a data point, and below each dot is its coordinates. So for example, this case, this dot falls at coordinate x1, y1, right? 1, 1. Or xy rather, excuse me. This dot falls at xy coordinate 2, 2. X is always listed first and y is always listed second. This dot falls at coordinates 3, 3. So the values for this case are 3, 3. And the coordinates for this case are 4, 4. Now, there's a 5th data point that doesn't seem to fit the pattern, and that is data point 2, 4. It kind of sticks out from the others. You may not have noticed it as sticking out, but there will come a time after we do some analysis with scatter plots that it will appear to stick out. So the main thing I want you to glean from this handout, this is just an introduction to scatter plots for those of you that haven't worked or interpreted scatter plots before, and be cognizant of when we're referring to the x-axis, we're referring to the horizontal axis. When we're referring to the y-axis, we're referring to the vertical axis. Each case or each dot represents represents two pieces of information for right coordinates. This dot falls at 4, 4, 3, 3, 2, 2, 1, 1, and 2, 4. for our fifth item up there. And that's about it. Now, the second scatter plot, the item that's called scatterplot smoking X colds or smoking by colds, is this handout, and this too is an introduction to scatterplots of sorts. Here I added a little bit more information, a little bit more meat to what we're referring to here. As you can see from the top of this particular handout, this scatter plot is designed to help us determine, is there a relationship? Remember, that's what this unit this week is all about, is relationships, investigating and analyzing relationships. Is there a relationship between cigarette smoking and the incidence of the common cold? And so what I've placed on this makeshift handmade scatter plot are pieces of information from a sample of 38 people. N equals 38. So 38 people provided information for this scatter plot, and specifically 38 people provided two pieces of information. They provided approximately how many cigarettes they smoke, I think it's per day, is that right? Yes. As you can see below here, X equals the number of cigarettes smoked per day on average, and Y equals the number of colds reported in a year. All right, so I won't go to the trouble of pointing out each data point. I think you're more than capable of doing that on your own. I did take the liberty of labeling 3 specific data points just simply to demonstrate the concept of coordinates that we talked about a little bit earlier in this segment. So as you might be able to see, person A, which I've also labeled on the scatter plot, person A has coordinates of 2 and 1, which means they smoke on average 2 cigarettes a day and they report having 1 cold a year. Person B, their coordinates are 4, 2.5, and they report having or smoking 4 cigarettes a day, X, their X value, and 2.5 colds a year, their Y value. Person C has coordinates, and they're labeled, as you can see on the scatter plot itself. They have coordinates of 6, 7, so their X value is 6 and their Y value is 7. They report smoking on average 6 cigarettes a day, and also report experiencing 7 colds per year, which seems like a lot. Now, when it comes to scatter plots, there are 3 things that we can tell from scatter plots. There might be more than 3, but there are 3 things that you need to keep in mind when you are interpreting scatter plots. And those 3 things are, is there a relationship? And we determine whether or not there's a relationship by literally eyeballing the data, looking at the data, looking at the way the data flow to see if there is a discernible pattern. In other words, do those data points appear to follow a pattern that appears logical? It may not make sense immediately to us, but is there some sort of pattern? That's what we're looking for. Now, in this particular case, I would answer that question, yes. There appears to be a discernible pattern. And in fact, that pattern appears to be as values of our X variable increase, so do values of our Y variable. And keep in mind what X and Y are. X is the number of cigarettes you smoke a day, and Y is the number of colds you report having. So it appears, I would say that yes, there is a discernible pattern. All right, so that's item number 1 that we can tell from the scatter plot. Number 2, we can tell if the pattern appears to be linear. Now that's a little bit trickier, and there's no trick and no magic to interpreting scatter plots. When determining whether or not a relationship is linear, as displayed in a scatter plot, what you're looking for is whether or not a straight line could logically fit into these data. And while I would say that a straight line wouldn't perfectly fit into these data, when I say fit, I mean passing through the middle of the data, leaving approximately half of the cases above and half of the cases below. It doesn't have to be a perfect fit, but here's the threshold. Here's the question you should answer. Could an argument be made that a straight line could fit these data? And I think in this case the answer is yes. I'm going to keep these segments to less than 10 minutes, so I'm going to go ahead and cut this one off and start another one in a little bit. This is part 1.